Now, a very quick note that whenever you say new and say what type, like int or character or whatever, and say how much you want, then you should also be sure that the allocation of this memory is contiguous, right? It sequentially populates everything in one memory block. There is no fragmentation involved. There's no any kind of fragmentation. They're all sequentially and nicely placed in memory, right? So you can view this as a single memory block that gets allocated with respect to how many you want. Thing number 2 to remember is that you actually have to say delete dynamic array at some point if you would like to avoid memory leaks, right? So if new allocates, delete deallocates that memory. Now, you may also see this curious syntax for square brackets. Every time you ask for more than one element like this, when you delete, you need to use this syntax with free store memory manager. And what it does is this. Basically, let me try a cleaner view of this. So here's your memory, right? And so somewhere here around like middle of this, so we have the stack, right? We have heap or free store, which we use right now, free store memory manager with new and delete. Then of course we also have globals, which we don't use in this program. It's normally called a data memory segment. And we have text, where all the code is going of our program, right? But right now, when we allocate more memory, it's getting allocated somewhere here. The memory that stores this 100 integers is somewhere here, and basically the heap is growing this way, and as we're making function calls, the stack, which keeps track of local variables, keeps growing this way. And these are the high memory addresses, high, and these are low memory addresses. Physically, if you would like to look at the numbers. Now, so when we say new something like int and specify the size, how big this block of integers should be, what happens is that this memory manager that gets involved, we can also say free store memory manager. What it does, it creates like a small little database of chunks of memory that you have allocated. So somewhere here in this heap memory, there's like a tree structure which looks like this, right? It basically has branches, and anytime you allocate something new, it essentially has internal pointers to these memory allocations that you have already attempted, right? So this free store memory manager is the thing that has like an entry point in there, and it keeps track of everything that you have done. So when you say delete, right? When you say delete square brackets, and you specify, basically what you specify the location where it's supposed, the return of memory is supposed to happen, right? So this is some kind of pointer that we've used. So this pointer is used as an entry into this tree, okay? And then what it does is that usually in this this information remembers the size of the memory block that was allocated. So basically, the syntax that square brackets basically tell memory manager that this is not a single integer that was dynamically allocated, but the entire block of memory that was allocated, and it basically knows how much memory to return back to the operating system, right? So that memory essentially gets returned back to the operating system after delete and is no longer available. Now, if you do not place delete in your code, just like this, it's not a big offense if you know that your program is about to end. By default, when your process ends on any operating system, any dynamically allocated memory, which is being kept track of by the memory manager right here, right? All of that memory is going to be nicely and safely returned back to the operating system. However, if you're using program that does something like this in a loop, you need to be able to find a way to deallocate memory. So this is the lowest levels of it, and by the way, internally, right here, all that you need to do is like this, like dynamic memory, and say element number 0 equals 1, right? You can start using it just as a normal array syntax, and you can say other locations are available and so forth, so you can basically use a loop to basically store values and read values from this dynamic memory, because from this point on, because the pointer allows the square bracket notation for indexing based using that pointer as the base memory address and index, which would be pointing to specific offset from that base memory address. It basically gives you access to that memory, and this is all you have to do. If you need to say display it, then you can say std cout display the value from index 2. So this is essentially demonstrates the usage, right, of dynamic array. All right, so that's the usage of it. We will have to say much more about this dynamic memory allocation in the future, because we would like to learn also in the future that there could be, there are some choices for us to use. In fact, most of the C++ programmers nowadays will actually choose an object which represents dynamic array. So let's talk about that.